Welcome, everyone. We're just getting started and letting folks join the webinar. So let's wait just a minute or two more for those of you who had your reminders right at the bottom of the hour. We're welcoming those individuals into the meeting. So just a minute or so more, and we'll get started. While we're waiting, I do want to remind you that this Friday is an important date for all of us. We have a deadline for our abstracts for technical papers for our upcoming conference in Orlando, Florida this fall in September. So if you have a paper, a technical paper that you wish to present to promote your company and your work, please go to our website. It's a very simple procedure of submitting an abstract. So just a quick reminder, and I will probably remind you again 2 or 3 times here before the end of the hour. So thanks for doing that. So just another little bit. I think most people are coming in. We have a very good audience today. So why don't we go ahead and get started? And we're really pleased to have Cimteq with us today. Welcome to today's IWCS webinar. My name is Dave Cadu. I'm honored to be the CEO and director of IWCS, and I'll be your moderator today. We welcome you from wherever you are. We do have an international audience, so good morning, good afternoon, good evening, and for those of you really early in the morning, good night. So again, we have a few housekeeping items that I want to share with you. One, please note that as an attendee, you are part of a larger audience, and during the presentation, all participants will remain in listen-only mode. And this is being recorded for rebroadcast. So please be respectful of that. We encourage you to submit your written questions to Chris, our presenter, using the chat function at the right of your screen. So not the Q&A, but the chat. So after typing in your questions at the space at the bottom of the chat, hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. So just you can queue up the chat button and submit your questions as the presentation goes on. Our IWCS webinar series is hosted by the Cable and Connectivity Industry Forum, and today we are honored to welcome Chris Huntley, the CableBuilder Product Manager at Cimteq by UL Solutions. Very interesting and good opportunity to learn, focusing on the flexibility of CableBuilder and different ways to design a cable, and how easy it is to design a variety of cable types in a way that suits manufacturer-specific processes and procedures. Chris has 27 years of experience in the cable manufacturing industry and is responsible for defining and managing the roadmap for both Cimteq's CableBuilder Enterprise and CableBuilder Go cable design systems. So Chris, welcome, and look forward to hearing your presentation.
Okay, thank you, David. Good morning, good afternoon, everyone. And yeah, thank you for joining this webinar. As was said, I'm Chris Huntley, CableBuilder Product Manager, and I've been at Cimteq now for 3 years. Spent 27 years at Aberdare Cables in South Africa in the design office. What I would like to cover in this webinar is I would like to give a brief introduction of Cimteq by UL Solutions, or a brief introduction to. I would like to give a very short overview of CableBuilder and the key benefits it offers. And then the focus of this webinar is on cable design. And what I'm going to be looking at is the different ways that you can design cables to hopefully show you that it can be in the way that you're used to designing cables. There is no set rule within CableBuilder. It is a very flexible solution, and it allows you to design the way you're used to doing it and in a way that you want to do it. So it's not rigid at all. And hopefully I've got 5 practical examples that I will take you through. And I think I'm a little bit short on time. I would like to have done more, but I'll be more than happy to take any set up any meetings with anyone who would like to take it further based on their own product range. So just quickly about Cimteq by UL Solutions. We were founded in 1998 in the United Kingdom. Our head office is based in Wrexham in Wales, and it was from individuals from the cable industry itself. And I'm sure, as most of you know, that last year we were acquired by UL Solutions. The product we make is we're software developers, and it's a cable design, costing, and manufacturing solution. So it's software that's unique for the cable industry. We have 3 products. CableBuilder Enterprise is, you could say, our flagship product. CableBuilder Go is a sort of lesser offering to CableBuilder Enterprise, which targets the smaller customers. And then Cable MES, which is our manufacturing solution. And our aim is to provide industry-specific software solutions to the cable manufacturing industry. This is just to show you some of our customers. We are present in more than 100 cable manufacturers across 5 continents. And you can see some of the names there. There's some very big cable companies there, some in the Americas, some in Europe, some in the Middle East, some in Africa. So we do have a very good global presence. CableBuilder modules. The first 2, well, CableBuilder is a modular offering, which means that you only pay for what you need. You don't have to buy everything if you don't want to use everything. These first 2, the design and the quotation module, they are part of CableBuilder Go as well as CableBuilder Enterprise. The design module allows you to create BOMs, routines with costs, and then additional information like data sheets, brochures, etc. can be generated against these designs and routines. And it can be in a single or a multi-plant environment. The quotation allows you to generate accurate cost per design length with a full breakdown of costs. So in other words, you can split it by packaging, strategic metals, etc., and you can generate reports. These modules are only available to CableBuilder Enterprise. So you've got the manufacturing allows you to calculate costs based on actual manufacturing criteria. So actual scrap as opposed to scrap per length. You've got the QA module, which allows you to define, capture, and compare data with validation. So a really good quality tool that you can use in your factory. We've got the design wizard, which allows the quick generation of designs based on predefined templates. And it takes you through a series of questions to create a finished design. Then we have a 3D module, which is currently under review, and it is really looking good. That generates really nice photorealistic images in 3D of your cables that you can use in brochures, etc. And then we offer integration to third parties like ERP, MES, and things like that. This is an example of some of the cable types that you can draw in CableBuilder. These images are all generated from CableBuilder. And the rule really is if you can define the logic, you can design the cable. As long as you know how you want to achieve to the endpoint, you're able to do it. So some key features of CableBuilder Enterprise, and this really is a very condensed list. If you want to hear more about CableBuilder, please feel free to call me and we can go through it. What we found as well, just worth mentioning, is traditionally what our customers battled with was when they bought CableBuilder was the time to implement the software into their and get it live in their factory, because they needed to do all the setups and the processes, etc. We have now created installation databases. We've got a metric one, an imperial one, and one that does both. These have got all these predefined rules, processes, cable families, etc. set up, and we give it to you with that setup. We give you the rules we've used, and we give you user instructions. You can then, after the initial training and everything that we've done with you, you can have a look at how outputs are generated. If you're happy with it, you can keep it. If you're not happy with it, you can change it to the way you want to do it. But the nice thing about the way it is now, you can take your time and understand the system nicely and do it as and when required. So some key features of the design module: it's fully customizable outputs according to individual needs. What this means is you take it and you can write the formulas. So if you don't like what we've done, it's very easy for you to take it and change the formulas according to the way you want it to generate. If for whatever reason you want A plus B to equal C instead of D, you can do that. Very easy. So whatever the outputs are, you are in charge of those outputs. It's got a multi-plant environment allowing design alternatives. So what this means is you can design the same cable in 2 different locations. It could be America and Europe, but each cable will have its own individual routing based on its location and on individual raw material suppliers if they are different. And you as a factory can then understand which is the best factory from which to deliver your cables and manufacture for orders. It's got design, approval and workflow and an active status. What this means is before you accept a design for manufacture or for quotations or send it to your ERP, you can define the rules that it must go from person 1 to person 2 to person 3. So it has to be reviewed by the design office, by manufacturing, by industrial engineering, or whoever you define. It's entirely up to you. You don't have to use it, but the options are for you to take it through these steps and put rules in place to say this may not be quoted on or this may not be manufactured until the following criteria is met. You then have the active status. What that does is it locks a design for editing. So if you make a change or if a specification is updated or something happens that you need to update that design, you do that by versioning it. So what the version does is it gives you a full history of that design from the day it was first created until whenever. You've got a full history of all the changes, when the changes were made, who made the changes, why the changes were made, and on what date. And you've got the ability to retain all the documentation associated with this. And that's one thing in my experience that auditors love is for a cable manufacturer to show that they're in charge of their design and they've got full document retention and they've got a full history of what they did and why they did it. Really, for me, one of the big pluses in the system. You've got automated design outputs for BOMs and routines as and when required. So like I say, you set up the rules. Then when you create your design, you push the button, it runs all the formulas and it generates the cable according to the dimensions you want, the masses you want, and etc. So everything is done at a click of a button. We give you default reports like data sheets, product brochures, etc., and you can use them. Everyone loves a report, but in my experience, cable manufacturers like their own flavor on that report. So we give you examples of reports, and you can then either ask us to help you create your own, or if you've got the skills in your IT department, they're able to take what we've given you and modify it towards your way. And then we have validation. Validation is checks that you can put in place to if it's extrusion, if there's no thickness put in, it will raise a traffic light. If there's taping and it doesn't have an overlap, for argument's sake, you can raise the flag to say this has not been done. So based on your experience, you can identify problem areas and you can put validation in place to make sure that these are in fact done the way you want it to do. So just quickly to compare a flat BOM versus sub-assembly, because these are the 2 ways that typically people manufacture or design. And just to say there is no written rule in CableBuilder that you should do one way or the other. This is typically, companies normally decide which way to go based on their ERP and how the ERP is set up. Within CableBuilder, there is no rule to go one way or the other. They both have their own merits. They both have good ways of doing it, and it's entirely up to you. But a flat bull is also known, or a flat BOM also known as a flat bull or a single level BOM. What this is, as you can see here, you've got a full design from the rod break to sheathing. So it's a low voltage multi-core cable. It's got all the operations, so it's going to go through 10 machines. So you obviously can only do rod break. You need to finish that to go to wire drawing. You need to finish that to go to stranding. But it has all these machines in one structure on one code. And I suppose that the one characteristic of this is conductors, etc. You may have structures existing in multiple flat bombs. If we look at subassembly, which is also known as a multi-level bomb, this comprises a single design code or structure containing a single operation and its associated materials. So if you look at this image here, sorry, just my glasses on. If you look at this image here, you've got one machine for the structure. If you look on the left-hand side here, every code here represents a separate subassembly code. So it's a number of building blocks. So one building block can be contained within multiple upper level designs. So like I said, it's entirely up to you how you want to design, but CableBuilder allows both, and you can do a combination of both. And I've actually got an example that shows that shortly. So these are the 5 examples I would like to do. It's definitely not the only list of ways you can design a cable. There are other ways, but like I said, because of time constraints, I thought I'd stick to these 5. I think it gives a very good representation of it. And hopefully it does pique your interest and you would like to give us a call and to talk about how we can help you in your company. So without further ado, let me go on to CableBuilder itself here. So the first design I'm going to do is just a simple, mostly manual design, and I will take you through it. So in CableBuilder, we're going to create a new design. So I'll just give it a demo rod break. Let's do a rod break design. You can see here's a standard. We split our designs into standard, which allows people to define rules according to different standards and also just to group your designs in a manageable way. The way I've set this up, you always go to the header first. The header is information associated with the full design. So here we will say the specification. I don't have to input information in all of these fields. I've left them there just to sort of illustrate you can have fields there that are optional. And you can define mandatory fields as well. But let's say this is to the IEC. It's manufactured. The rod break, this item nature will be used to generate a description. And we give a unit. This is a metric database, so we design per meter. If it was imperial, it would have been per foot. So let's just keep it at that for the header. And like I said, this is mostly a manual design, so you'll see a lot of manual things I'm doing here. Then we need to add the layer. The layer basically is the process of the operation we're going to do. We want to draw a wire down. We want to do a rod break, so we'll add the rod break process. We need to add a material, so we need to add a copper rod. And you can see the way I'm going here that the system allows all the things you'd expect of a modern system in terms of wildcard search and et cetera, et cetera. So let's add our copper rod. Now within CableBuilder, you'll note there's different sections here. Typically, for I'd say 99% of the time, you only have to enter information in the layer selections. So what it does, it makes it quite clear to your design engineer, I need to input stuff here. If it's mandatory, if he has to put something, you'll note there's a little red asterisk. This tells you it's mandatory. If I try to save that now, it'll tell you need to put in a value for nominal dimension. So you can define those that maybe you feel people may miss. So let's make this a 2.13 millimeter wire. And I'll just save and view that. So what we want to do now is add a machine to this. So I'll add an operation and our machine goes in the operation, but I'm just going to view that from now. The operation is the machine that you costed on and your default machine. This is typically read in from the resources. A resource is a collection of machines that can do the same operation. So within this, if I say resource, we want a drawing resource. That's the type we're going to do wire drawdown. And I save there. If I save now, you will note based on the item nature I entered, the machine gets added, and against that machine, all parameters associated with that machine get calculated. So the result here is we already have a speed of the machine, we have a cost of the machine, and we have a runtime of the machine. So this is an example of a slight automation. So let's just go out of there. So what happens now, we've got alternate resources here. So within the same factory, if you had 2 or 3 rod brake machines, you could add other rod brake machines here that would each calculate according to their own parameters. So you as a manufacturer know that if I get an order for this and this machine is busy, I've got machine number 2. And it's also given the operator target speeds, etc. to run to. And it also gives you as the manufacturer insight into what the costs are of your various machines. But that's basically my design. I've got a process, I've got a material, I've got a dimension and mass, I've got a cost, I've got a machine. This yellow exclamation mark here tells me I need to run all my formulas. Something is done, so I need to push process to run all the formulas so everything is calculated. So this is a very simple design done from scratch. You'll see if I've got the design drawing here, there is a little drawing. And we've got a little report here that comes as a standard, which summarizes the cost of the raw materials at the top per kilometer or per 1,000 feet, which gives you the mass of the materials. We've got provision for allowances, factory or process allowances, as well as scrap allowances. And it gives you a cost per kilometer. In the operation, it gives you a list of the machines required, the total time taken to manufacture, and a cost of your labor and overheads. And at the bottom, a full cost of manufacture. So that's how you do one from scratch. What I'd like to do now, and because of time, I'm going to show you a different way to create a design, but let's take this 5 strand. So if we look at this drawing here, you'll see it's a little bit slow at the moment. I do apologize. You'll see it's a 7-wire conductor here. So if I take this, you can copy a design alternative. What a copy does, it takes the whole structure that I've just created manually and it copies that whole structure. So let's just copy this. And what I'm going to do, I'm going to make this a small flat bowl with a strand and an insulation. So I've copied the existing strand that we've got. What I want to do first off is I want this to be, because it's going to be insulated, I want it in a low voltage standard. And then because I've got certain automations in what I'm going to show you now, I just need to tell the system where to look to define these automations. So the insulation will help me generate a description. The voltage will be used to generate the thickness of the insulation based on specifications. So let's just save and view that. So first off, this is an example of a conductor table. We find that a lot of people, because a conductor is such a big cost in the cable, they automate the masses and the dimensions based on actual values in a lab. You don't have to use this table, but we find a lot of people do it, like I said, because it is such a big cost of the cable. So I'm going to create the 70 class 2 copper circular compact. And that should then give me these values here, 19 wires of 213, an outside diameter of that, and a mass of that. Those four columns I showed you here are mapped to these 4 columns in this process. So class 2 it stays at. I wanted a 70 millimeter here. I wanted copper and I wanted circular compact. What I am going to do here, this is still a little bit of a manual process. It's not fully automated. I'm going to call in the rod brake that I did earlier because that's a 2.13 millimeter wire. If I look at this conductor, this has still got the old stuff from the 5, but if I save, this should update to the values from the table that I showed you. So that's nice. We've got 19 wires there. We've got our dimension there. We've got our mass of 2627. Like I say, you don't have to use this table. If I say don't use the table here, it will calculate these values and you should see the mass and the dimension change slightly, representing that. So the mass came down from that and 10.01, sorry, changed to 10.118. But for the purpose of this, let's keep it there. So now I want to add an insulation. So I don't have to create a new design because I'm doing a small flat bowl. So I add my insulation layer here. And what's going to happen now, this is now an insulation table. We've got 70 millimeters squared based on the IEC specification. If the material is PVC and 600,000 volts, we expect to see a thickness of 1.4. If the material is XLPE, we expect to see a thickness of 1.1. So what we've got in CableBuilder is the ability to define raw materials and give them certain properties. So I'm defining, I want a general purpose PVC. CableBuilder will look in my raw materials and find every raw material I've identified as general purpose PVC. So what this does, it sort of eliminates human error. You don't get this whole hundreds of materials to search through. You can break it down to the granular and maybe even only have one. That's on PVC general purpose. And let's say I want a blue one. I'm not going to put the thickness in there. And you note we don't have materials down here. So if I save this based on PVC and the IEC, it should give me that thickness of 1.4. So there we've got the thickness of 1.4 as per the table. There it gives me the information from my lookup table. And here it's added the materials for me. So it's really nice. You can automate this way and avoid human error. Just to show you an example again, if I said this was XLPE, I only have option for XLPEs here. And if I save that now, it should change the 1.4 to 1.1 as per that table. There it is, and it's changed my materials to XLPE. So you see, it's really quite nice to be able to, let me just put it back to PVC. It really is quite nice to be able to define these in tables, and it ensures the integrity of your designs because there's less chance for human error. Because this is a flat bowl, let's just add another operation quick. And I'm going to add this resource as extrusion. So same story, if I save here, it will add a machine and give me the default values. And like I say, with these operation characteristics, it's an example only. We find that most companies do things in many different ways. So we don't try and force them. We give them examples to build off. So if we look at that, let's look at our drawing. So there we've got our compact conductor changed from 7 wires to a 19-wire compact and blue insulation. So for the third example, let me just create 2 more insulations. So what you'll note now is once I've got this structure of strand and insulation, if I use that to copy another one, I want a brown. I create a new code. I go into the layer when it lets me. Let's make that one brown. If I save and view there, my design's done. The thickness is done, the materials changed to brown. If I look at the drawing, we now have a brown conductor. Let's create another one. So let's create a 2. And so this will be one of the areas in the way I've set it up that there is certain areas you don't look in the selection. And I just did it to keep it nice and clean. So let's create an earth core so it's green, and let's give it a yellow stripe. And let's give it 4 so they're nicely seen. If we save and view there, it should replace the blue master batch with green and yellow as it has there. And we should have a green and yellow colored core. So you can see once you've got one, the structure for one, it really is very, very quick to create the next ones. So now let's create a mixture of a sub-assembly and flat. So what we're going to do is we're going to create a 3-core low voltage armored cable. We're going to use the installations we've created to do this. And this will now show you a new level of automation. So first of all, we go to the plant header. And again, so what this does, this tells the system, look at these values in the plant header and base the design of that. So if it's an IEC specification, obviously they've got rules for bedding thickness, sheathing thickness, etc. So it looks at that and it defines the rules based on that. So what I'm going to do now is first of all, and sorry, I pushed the wrong one, just bear with me. My apologies, I shouldn't have done that. I'm doing a semi-flat at the moment, not a full flat. So let's just remove these two. I could actually pretend it was meant just to show you the feature to remove things, but it wasn't. And again, I apologize, my line speed is not the best at the moment. Okay, I'm going to, it looks like I might have lost connection.
Yeah, Chris, we're just seeing a white screen.
Yeah, my line, we've just come off load shedding now in South Africa, and I don't know if I've just lost connection. So just, if you can just give me 2 seconds, I think this should fix itself shortly. Or what I can, it's,
no worries, just
Murphy's Law, Murphy's Law.
There it is. I think we've all come to learn these internet issues on these.
Yeah. What I'm going to do, I'm going to close this off and I'm going to reopen it.
The sad realities of online meetings. Here we are.
Yeah. Okay, so I'm going to just create that again. A demo for a semi-flat. And so, like I said, I'll go to the plant header. I'll define what I want this to be. The specification, as I say, is used to define what the thicknesses, etc., should be based on specification. So let's have a look at that. So I'm now going to create a multi-core low voltage cable. Let me add the layers. So first of all, I want a layup, and I'm going to add the 3 insulations that I've just created. In selections, you'll note I've got some default values there. So in the interest of time, I'm going to let the default values come in and just manually enter the ones that don't have a default value. So what you'll note now, I've added those, operation and resource are automatically getting created. And you'll note as I go through these layers, all I'm doing is entering stuff in the selection layer, and the materials are being added based on the selections I give. So I'm not actually adding any materials. So let's say I want a flame retardant tape here. So same thing as with the insulations. Let's say I want it helically wrapped with an overlap of 15% and a left-hand lay length. If I save that, you'll see the material has been automatically added for me there. If we now create a bedding, and this is a really nice example of how quick you can create a design once you've got it set up. Let's say we want a PVC and we want a black bedding, and we want that material. I'm not going to define the thickness or add the materials, but as I save and exit, you'll note the materials are added for me, the thickness is defined, the operation added, as well as the resource. So let's create some put some armor on this. So if we say we want wire armor, it's round, we want 100% coverage, that's good enough for this. It's got a default for the lay length. Again, the materials are added for me, as are the operations and the resource. Let's give it a sheath. There. And this one we can give it, let's give it, excuse me, PVC again. Make it black PVC. I won't give it a thickness, and let's give it 2 blue stripes. So you'll note it's added for the black material and the blue for the stripe. And let's put this on a drum. So we want a wooden drum with 500 meters. If we save and view that, you'll note that the whole design structure has been created. All the materials are there, the operations are there, the resources are there. If I process this, it'll run through all the formulas. So even with my little glitch that I had, it hasn't been long that I've been able to create this 3-core cable here with armor. And like I said earlier, if you look at the BOM summary, this grows. So you've got all the raw materials required to make a kilometer with the costs. You've got all the operations required to make a kilometer with the costs and a total cost of manufacture here. So really quite nice. I've got 2 more that I want to show you. So I just need to. So I've got a full flat bull design here. And it is an armored one. Sorry, not flat bull, sub-assembly. So you'll note here on the left, this is also another feature I can show you. This is the full structure of this. Every code represents a sub-assembly. And as you can see, I can navigate to anywhere in this cable from this, but remain in the top level of the cable. It really is quite nice. If we look at what this cable looks like, this is a 50 mil 4-core, low voltage with circular conductors. Let's say we want to create a 50 mil 4-core with sector-shaped conductors. We can copy this, and we say multi-level copy now. So what it does is it opens up every sub-assembly in this design. So I want to just say recode these to the level I want. So I just want to recode down to layup. And at layup here, I'm going to call in my sector-shaped conductors. So I've given new codes for these, and I'm saying, don't worry about those, keep as is. And we go. And this normally takes a little bit longer than the normal one to create a design. It's still maybe 15 seconds, but because it's creating codes for 6 or 7 new codes. You'll note here, so there's my new code. If we look at the tree, it's called all the new codes in. So I don't have to go and individually call it into the different sections. But let's go into layup, because this is where our change is going to happen. So we want to get rid of these circular insulations and that filler. So we can just add this. So again, not yet fully automated on this one. It can be done, but I haven't done it for this. And then let's add the sector shaped. So I want 50 millimeter squared, S4 for sector 4. There. I want insulations. There. So I can just add those 4 to my design. I'm just going to change the order of 10 and 20. The reason for that being on layups, if you've got a core with a stripe, that should always be the first core in your BOM line. So it shows on the drawing. If we go to the top of our new code, we just process it through quickly. And so we went from a 4-core with circular cores. We've now got a 4-core with sector shaped. If you note here, this is the new one. It's got a dimension of 38.4 and a weight of 35.1. That hasn't actually worked nicely for me. But what you will normally find is the dimension and the weights will reduce as well, which you would expect to see in a sector 4-core. But that's how quick you can do that. For my last example design, I want to do a full flat bull, fully automated. So again, always the first time we go to a header to define what we want. So in this one, I want a full flat. I want IEC specification. I want the voltage of that. I want the meters of that. And item nature, we're going to take it up to sheathing. What I've got here, I've created this tab. This tab, you're going to define the cable you want. So we say we want a 25 millimeter square copper. We want PVC insulation. We want 3 cores. We want a PVC bedding. We want steel wire armor. We want a PVC outer sheath. A wooden drum with 500 meters. So that's telling me the design I want. And that's saying according to that specification. and voltage. So if I save and view that, what it will do off the bat is it will create the structure for me. Now, my exclamation mark says there, I have to process this design. So what this process will do is it will add all the materials, the operations, the resources, and calculate the masses and dimensions for me as well. So there we've got it there. All my materials are in. I've got these dimensions. I've got these masses here. I've got the cost, everything. If we look at my drawing, I've got my 3-chord armored cable. If we look at my BOM summary, I've got the materials that make up a kilometer of cable with masses and costs. I've got the machines that make up a kilometer of cable with run times. According to my homemade standards, this will take 12 hours and 12 minutes. And a total cost of the cable and of labor and overheads and a total cost of manufacture. What else we've done, I mentioned earlier on that we have default data sheets. So within the header, there's certain drop downs, and I'll show that to you in a minute. But what that does is it comes, you've got a demo data sheet. So this will give me a header of this design, it will give me a drawing, and it will give me certain things in the data sheet. So there we've got the header, you can put your company logo, you've got the description of the design there, the drawing of it there. I'll show you where these features come from in a minute. Don't look at what they're saying. These are just purely for illustration and used as examples. And then a breakdown of the cable construction. The intention of this is people then take it, they use it to copy and create their own from in the way they want to do it. Most people have different looks and feels to their data sheets. I haven't put electrical calculations in here. It is possible. I did it at my old company. A lot of people do it. The reason I've left it out of the default database is if you do them yourself, you'll understand that it looks at material types, it looks at thicknesses, it looks at positions of materials and cables, etc., etc. It looks at a lot of stuff related to the cable. Because CableBuilder is so configurable, I do not know up front how you will configure it in the future. So what we do, we give you the examples, we show you how to do it, and if you want us to help you with doing the other calculations, we're more than happy to help you, and we're more than happy to help you create these reports in a way that suits you yourself as well. But the power is within your hands to do it. Just to show you where that did come from, and you will note as well that when I've created that, a description has come up. So we give proposed example descriptions, etc. In my experience, people will do this all differently. So what it does is it ensures consistency. If we go into if for argument's sake this was done wrong, let's say they didn't want 25, they wanted 50, they wanted XLP, and they wanted a 4-core. It shouldn't have had a bedding, and it shouldn't have had armor. I'm going to regenerate it. On that data sheet, just to show you, this is what I've got. These are just drop downs. You can select whatever. So that data sheet will put whatever's on this page. And like I said, it's illustrative only. So if I save and view that, what it will have done is delete my previous structure and update it with a new structure I've defined. So you'll note there's no bedding and armoring. When I process it, it will add the materials and run all the calculations. I hope I'm not losing. This is going a bit slow again. I apologize for my line speed. It's just Murphy's Law. It happens at these times. There's that. If we look at the data sheet, this should now be updated to an unarmored 4-core. And so there you've got it. And we've got a green and yellow in there and everything as well. And so you can see the value that you can do. If you take the time to set the system up nicely, based on what we've provided, you can really make this extremely powerful and useful. That really is what I've got to show. Like I said, there are a lot other ways you can do this, and I do encourage you guys, if I have sort of whet your appetite, please give me a call or contact Cimteq, and we can look at a full demo according to your factory and your needs. And so really now it's on to Q&A, if there are any.
Chris, thank you for that. It was excellent in spite of the connection issues. Not to worry. I think the main points were well received. So thank you for doing that. I do want to remind the audience that you can enter some questions into the chat function, and we can direct those to Chris. Chris, how much of the design process can be automated?
David, in real terms, it's entirely up to individual customers. You can do it 100% fully automated. You can do it 100% manual. You can do a mixture of both. What we've found with customers that we've implemented, some people think we've done too much. Some people say, no, I need more. So we've tried to get a middle ground to give examples of how you can do it, but then we leave it to customers to take it to whatever degree they want to do it. But ultimately, you can do it any way you want.
That's great. Okay, I think that wraps us up. Again, for the audience, this webinar is recorded and will be posted on our website within the next week or so you can review it again. But I will go ahead and provide you now with Chris's contact points. So here, bear with me. And hopefully, Chris, am I getting this right? Do you see it? Okay.
Yes, that's
Chris?
100% correct. Yes.
All right. So you can contact Chris directly. You've got a telephone number in the UK number, the 44 number, as well as his email address, and very responsive. The Cimteq team is excellent in responding quickly and effectively. They will also be with us at IWCS in September. So please feel free to reach out to Cimteq. So Chris, thank you so much for presenting this very interesting topic. Certainly an excellent tool. I learned an awful lot, even though I thought I knew it, a lot of it. This is a great way to learn the nuances of design. So each of these IWCS events occur on a monthly basis. They will be archived on the IWCS website, as I mentioned. The IWCS webinar series will conduct technical paper presentation webinars each month, and our next scheduled webinar will be on Friday, April 21st, which is just 2 days away. So each of you should be receiving an announcement for that event. So please feel free to share our announcements with your colleagues so that they can join in and register as well. I don't see any last minute questions. Becky, do you see any that I may have missed?
No.
Okay, good. Again, a friendly reminder, we are very eager to promote you and your company and your work, the important contributions that are really bringing our mission critical industry to life, and a lot of neat things happening, and we want you to have the opportunity to present that work at the IWCS 2023 Cable and Connectivity Industry Forum. So you have a few days left until Friday to put in your abstract. It really doesn't take much for a one-page abstract to let us know of what you're working on and what you would like to present. So if you haven't done so already, please consider entering an abstract. Just simply go to iwcs.org. And it's a real simple process. So hopefully we'll see a few more abstracts here submitted before Friday. It's important that we recognize and thank our IWCS partner sponsors who greatly contribute to the success of our industry forum. Without their strong leadership and generosity, we would not be able to bring these important technical innovations and information to you and our global community. So again, thank you to these leading suppliers in our industry for your support. And also, very importantly, we want to thank Cimteq by UL Solutions. Fantastic information, helpful information for our industry to expand and grow. So again, Chris, thank you so much for your time and your efforts. And again, as I've mentioned, please save the dates of September 17th and 20th in Orlando, Florida. For over 71 years now, we've been delivering the industry forum, and we are the recognized leader in showcasing new technologies and cable and connectivity products, processes, and applications. Our event will be at the Gaylord Palms Resort and Convention Center in Orlando. So feel free to bring your family and reacquaint them with Disney and Universal, and we'd certainly love to have you as part of our conference. So watch your inbox, social media, our website to learn more as the exciting information becomes available. So please visit IWCS.org as soon as you can. So thank you for participating, and take care.